Used to wander line by line. Now it's fields in a fixed design. Trimming edges of the thought. Pressing answers into cards. Punch it up. Make it fit the line. Punch it up.
Did you know that Henry Ford might be responsible for laying the groundwork for neural networks, digital twins, and AI? Before there were servers humming in data centers, there were conveyor belts humming in factories. Steel, grease, and repetition. Henry Ford didn't invent the automobile. He optimized the movement around it, and that changed the world.
The assembly line reorganized complexity. Instead of one person understanding the whole machine, each person mastered a narrow slice of it. Throughput increased because variation decreased. The work became predictable enough to measure and refine. Decomposition changed scale. When tasks are discrete, you can rearrange them. You can optimize them and replicate them across facilities. Efficiency stops being personal, and it's now architectural. So that instinct, breaking complexity into manageable units and tuning them for output, shows up again in modern computational systems.
Exactly. One person attaches the wheel. One person installs the engine. One person tightens the bolts. You don't build a car. You perform a motion. And over time, that motion becomes muscle memory and carpal tunnel syndrome, right? Like, I mean, there's no way out of that.
Did you ever see that movie, The Founder, about the Ray Kroc
No.
and the? Oh, you really need to see. Yeah, you need to see that, because this is like that whole repetitive movement personified. The Mac brothers, the original McDonald brothers, they built what they called the Speedy system, right? And they show it in the movie where they literally lay it out on a tennis court and they put, chalk drawings and they move them from spot to spot. And it's,
Dude, there was only one way to make a French fry.
Right.
When you were on the fry station, that's all you did.
That's
yes.
right.
And you can still
mechanized.
get something to the you can get something to the window in 45 seconds if everybody did their job. Yeah. At McDonald's, there's something called Founders Day, where people come from the offices to work in a restaurant, and they get unmercifully dragged while they're there, like, by a bunch of 16-year-olds. Yeah, it's good.
It's a really good movie, though. You should check it out.
I'll go check it out, yeah. We romanticize factories, though, right? Black and white photos of workers in caps and coveralls. But the real revolution wasn't aesthetic. It was fragmentation. Work that once required holistic knowledge was broken into micro actions. You no longer needed to understand the entire machine. You needed to understand your station. That's efficiency. That's also a philosophical shift, right?
So this guy, Frederick Taylor, ran a structured time and motion studies at places like Bethlehem Steel. He didn't just observe the work, he pulled it apart so you could decompose it. Loading pig iron became bend, grip, lift, carry, drop, return, right? Over and over again. Each motion was timed. He literally stood at the top and watched and had a stopwatch watching this. The fatigue rates were tracked. Different load weights were tested to see which configuration produced the highest sustained output across the shift. They discovered something kind of counterintuitive. Smaller shovel loads moved more material per day because workers maintained pace longer. So what they do? They remade the tools. They remade the shovels. Floor layouts shifted to reduce walking distance. The rest intervals were scheduled mathematically. Planning separated from execution. This sounds kind of dystopian, though, right? Like,
dude, FedEx still does this.
I know.
How many steps from the front of the truck to the back of the truck, and how long did it take you to get there? Now, how many things are in that truck? This is how long it should take you to do your route. It's crazy.
but right, you build that. You take the skill, and that mitigates upward into system design, or migrates upward into system design. Variability narrows. Output becomes the function of the configuration that you've arranged rather than the sort of individual discretion. Once the work is decomposed this way and measured, it again optimized, copied, scaled. In that structure, you have to observe, quantify, standardize, refine. That becomes portable. You can redo it in a steel mill or on the factory line or, producing software or frying French fries.
There it is. There it is. And that logic scaled, right? From factories to offices, from time clocks to punch cards, and from steel to paper. Like we brought that into our corporate space, that exact like way of thinking. I don't know. Don't you think there's something poetic about punch cards? Tiny rectangles of cardboard with little squares in it. Your work reduced to perforations. You didn't type commands, you punched them. And if you drop the stack, okay, I've once or twice dropped an audit binder, and if those pages weren't numbered, I was screwed. Same thing for these. If you drop that stack, it really was chaos for sure.
I, I actually had a box, like when I was a kid, I had old punch cards. I had a whole box of them, and like actually multiple boxes. They came from somewhere, like, my mom had them or something. She was at a sewing factory, so they used them for something. And, I just had, just reams of these punch cards. They played with them, made stuff out of them, did different things with them. So, when I was a little
Lucky.
kid. Yeah, I know. But each IBM punch card carried 80 columns. If you know anything about displays on machines, 80 columns is like, it's the same. There's a reason why there were 80 columns displays. Every column mapped to a character position. Oh, look at that. A misplaced punch altered the instruction. So programs existed as ordered stacks. Sequence was the logic that you input, and jobs were submitted in batches and processed on centralized machines. So your errors meant repunching, and resubmitting the entire run, and that structure governed the execution itself.
So, and here's what's interesting. At each step, the system optimized not creativity, but consistency. Factories optimized motion. Punch cards optimized instructions. Mainframes optimized calculation. Now we're optimizing cognition, which sounds way more scary.
Yeah.
So, okay, before we go any further, we need to pause because we just jumped from punch cards to like neural networks. So like I want everyone like everybody understands like a GPU. I have one in my garage, right? Let's pretend someone is
I don't
listening
know,
to
does
this
Sam
thinking,
have one in his gaming rig? Does he have
yeah,
that?
I don't know.
Yeah.
What in the exercise room. It sounds like this all day. So if you're thinking I barely survived Excel, what's a neural network? So let's demystify it, right? A neural network is not a brain. It does not think. It does not have opinions. It does not wake up in the morning wondering about existence. It's a layered pattern recognition system. Here's the simplest way to imagine it. Picture a massive spreadsheet, but instead of neat rows and columns, imagine layers. Each layer contains tiny adjustable dials. We'll call them weights, right? Those dials determine how strongly certain inputs influence the next layer. You give the system an input, say a sentence or an image. The input passes through the first layer. Everything gets adjusted. Then it goes to the next layer. More adjustments. Then the next and the next and the next. And by the time it reaches the final layer, the system produces an output. That could be a word, a classification, a recommendation. It's not reasoning. It's not thinking. It's not smart. It's a statistical adjustment at enormous scale.
Yeah, so it's not thinking, right? It's calculating probability. If you've ever played, with the autocomplete on your phone, you've experienced kind of a primitive version of this. So you type, let's meet for, and it suggests lunch. Mine wouldn't say that. It would say meet for something else, like, I don't know, like dinner, or because I don't know. I don't go out to lunch with people.
Oh,
right
okay.
Why though, right? Because statistically, lunch or dinner or whatever the word is follows the phrase often enough in its training data. Now you got to scale that up. Instead of thousands of examples, billions, even trillions on some of the largest LLMs now. Instead of simple word prediction, imagine predicting entire paragraphs, code structures, medical probabilities, financial risk patterns. A neural network doesn't know what it's saying. It predicts what is likely to come next based on the patterns it has already absorbed.
So when people say AI understands, what they really mean is AI is very good at predicting. Like that's what they're saying, right? It's like it understands me. No, it's good at predicting.
That's right. Understanding implies internal comprehension of lived context. And so I think with ChatGPT, what was it? Dolly. Remember Dolly first came out? And,
Oh, yeah.
yeah, I know this. Like, people don't even like Dolly. That was so long ago. It would produce an image. the machine isn't looking at the image, the machine,
Right.
it doesn't understand that you just gave it a picture of, your dog or something like that. It probabilistically figures that out. The neural networks operate through that mathematical optimization. They adjust their internal dials, the weights, through the process called training, where they compare predictions against known answers and slightly tweak the weights to reduce error. So again, over millions or billions and sometimes trillions of adjustments, and the system becomes extremely good at approximating patterns. It's not really consciousness here, it's convergence of those probabilistic outcomes.
That's interesting because when we talked about punch cards, humans prepared structured input and the machine executed the instructions. Now we feed the machine massive data sets, and instead of executing explicit instructions, it builds internal pattern maps. So it's less do this and more figure out what usually happens. What usually happens, right?
Yeah. Punch cards, deterministic. AI processing, probabilistic. And when you layer that into your workflow automation, which we're about to get to, you're no longer just talking about automating tasks. You're automating pattern-based judgments in that. So let's keep this simple, okay? Unless you want to go into tensor math and big algebraic functions.
No, let's not.
But
Let me
modern
save
AI.
the listener. No, let's not.
Okay, side note here, like when I was doing math in university, because the math for this stuff has existed for a while. It's not like it's brand new math. It's just sort of used in a new context. New math. There's some new math too, but new math. What a tragedy. But
Right.
but but we had to like hand calculate some of these outcomes and do the tensor blocks and stuff. It's kind of a pain. Without a calculator, just write it down. Not fun.
With a fine arts degree, it's nearly impossible. So there you go. I can act like a mathematician, but I can't be one. There. That's
like
how
I have an English degree. I wasn't going to school for math, and I still had to do block calculations.
I should have gone to conservatory. Okay, go ahead.
All right. So instead of building cars, let's say on your assembly line, it builds answers. When you ask AI a question, and we're talking specifically about these large language model scenarios, it doesn't think, right? We've said that before. It doesn't think the way a human does. It breaks the task into steps. First, grabs your information. Then looks for patterns. Then makes a prediction about what comes next. Then it checks whether the prediction seems reasonable. Then it delivers the output. But here's the key. It doesn't make one big decision. It makes millions of tiny mathematical adjustments that add up to the final answer. And sometimes those adjustments go wrong. For example, when Zillow used AI to predict home prices in its Zillow Offers program, the system misjudged market pricing patterns during volatility. The probability model kept buying homes at prices that turned out to be too high. The assembly line of prediction was working exactly as designed. The real world changed faster than the model could adapt, though. The result was multi-billion-dollar write-down.
I remember that.
Yeah, it's huge. Bad news.
Yeah, it was big.
The system didn't fail because it stopped working, though, right? It failed because it kept working based on outdated patterns. So it was tightening the probabilities, but it was doing it on wrong data.
So instead of tightening bolts on cars, we're tightening probabilities in a sentence, a credit score, a medical image.
Ooh.
The old factory assembly line broke physical work into small tasks. AI breaks thinking into small calculations. And when those calculations reflect biases or incomplete data, the output reflects that too. So let's take facial recognition systems are known to be horribly biased. Like, we just know that. They often find the wrong person. It's happening a lot in Minnesota. It was happening a lot, right? Studies from researchers at MIT found that some systems misidentified darker-skinned women at a far higher rate than lighter-skinned men. That's not because AI decided to discriminate. It learned patterns from training data that unrepresented the dark-faced women. Imagine that. I mean, one more place we're unrepresented. In another case, Apple's credit card algorithm, launched with Apple and Goldman Sachs, was accused of offering significant lower credit limits to women compared to men with similar financial backgrounds, right? The system was optimizing risk, but the way the risk had historically been recorded carried bias. So it's really not. So here's what I would say. It's not the AI's fault. It's that they've been doing it anyway. They've been doing it anyway. They took all that data. They learned from this. And when it was making those mistakes at scale, it became obvious, right? The assembly line didn't eliminate bias. It scaled it. AI doesn't eliminate thinking. It reorganizes it. And if the inputs are flawed, the outputs are consistently flawed at an incredibly high rate of speed.
Yeah. The credit one is really fascinating because, we're talking, it learned from previous systemic bias, right? So if that's the most likely outcome, that's the pattern that you've trained it on, then you've trained bias into the model. And
it happened to a healthcare company too, right? It would take them a long time to tell 10,000 people, we're declining your coverage. I need a kidney transplant. Nah. I need an open heart transplant. No. It took them a long time to do that. What they realized at some point is, they take all that data that doctors had been doing over 10 years, throw it into a data set, and then teach a model from it, and then started doing these things 15, 20,000 a day. And you started to realize no one over 55 was getting a transplant. No one. And when they were doing them 5 or 6 a day, you didn't notice it. But as soon as they did it 10,000 a day, you noticed it, right? And all of a sudden, you're in trouble for being discriminatory. And when they went back and said, well, it's not us, it's the data, it's your data. You've been discriminating for 10 years.
Yeah.
Not okay.
Yeah. Real bias turns into trained bias then turns into biased results.
Yeah. Definitely.
Here's another way to picture it, right? So imagine finishing the sentence. The sky is
blue.
No, it's gray, Renee. It's gray. I live in England. It's gray.
Why is blue?
I know. You say blue because that's usually correct. I would say gray because pretty much from January till now, today was a beautiful day, but it was the first beautiful day in months. So anyway, AI does the same thing, right? But at scale, it predicts the most likely next word. Then the next. But sometimes the most likely answer isn't true. Large language models have repeatedly hallucinated legal cases that just didn't exist. In 2023, lawyers submitted a court filing generated by an AI system that cited fabricated case law. The model predicted what a real legal citation looks like, and it just made one up. It wasn't lying, it was guessing confidently. I like that. Guessing confidently.
It was a confident guess.
Yeah.
That's what con men do, by the way.
That's right.
That's
it. The system is optimized for fluency, not the actual, factual accuracy. That's the difference between probability and truth.
And here's where it gets more serious. When the prediction system moves into policing or criminal justice, probability becomes power, right? When Uber was testing self-driving vehicles in 2018, a pedestrian was struck and killed in Arizona. Investigation shows the system detected the pedestrian, but misclassified her multiple times. I mean, what did it think? It's a lamppost. Oh, no, wait. It's a post, it's
a mailbox.
It's a mailbox, oh no, I'm sorry, it's a dog.
It's a manhole cover.
The assembly line of perception, classification, and decision making hesitated. The factory was efficient. The blueprint was flawed. And milliseconds actually mattered. So when neural networks fail, they're failing at machine speed, which is not helpful.
Have you seen this company that is doing remote driving, and it was actually some dude in a call center in the Philippines, and he's driving remotely.
What the? Okay, wait, sidebar, but did you see lately, it was, whenever they do Tesla events, they have their Optimus standing out there handing out water. And so this Optimus is handing out water and people are taking it, it's handing out water. And then you see it do this weird thing where it goes like this. And it has nothing on, right? But it looks like it's holding a VR thing, and it throws it off its head and it collapses. So whoever was doing that backstage had to pee, I guess. And so he took off his VR head, and the whole thing just fell to the ground. And you're just like, So that's not real either. Like nothing's real.
Yeah. No,
Yeah.
it's not real. I thought it was cool though, to see, hey, we're doing self-driving cars, and actually it's not some self-driving car, it's some dude
Well,
in a data center.
do you remember when Amazon put in those stores where you didn't have anybody at the register and they're just
Yeah.
like, just pick it up and walk around and leave?
Yeah.
We can. No, it was a call center in India who picked you up as you walked in. And because you had your app open, they knew who you were. They saw what you picked up. They charged you. There was no technology involved at all. It was a bunch of cameras in a call center. None of it was real. None of it was real.
Yeah.
Yeah.
But it could have been real, Renee.
Yeah, one day, I guess. Okay.
Well, okay.
We can go
All
back
right,
to
let's
this.
go back to
All right.
this. So,
Yeah, okay.
so let's talk about this sort of shift here, right? So AI systems don't actually understand meaning. They detect the patterns and they assign likelihood. When those patterns change and when the data reflects past distortions, the system continues optimizing toward its objective function. If the goal is engagement, it amplify extreme content. Extreme. That dynamic has been documented across all the major social platforms like Facebook, now, Meta, our friends, where recommendation systems learn that outrage keeps users clicking. Like, how many times have we talked about this, right?
Right. Yeah.
The model wasn't trying to polarize society, not necessarily, right? Although I guess, I mean, arguable. It was trying to maximize time on the platform, and it optimizes the wrong thing, in this case, very well.
And that's the real lesson. The assembly line didn't remove responsibility. It moved it upstream to design, process, and oversight. AI is the same. When we automate thinking, we are really automating pattern recognition at scale. And when that scale intersects with finance, healthcare, hiring, policing, or public discourse, small design choices ripple outward. The question isn't whether the machine works, it does. The question is, what is it optimizing? Who trained it? What data shaped it? Who actually audited it? And who's responsible when the probability surface points in the wrong direction? Because once thinking becomes an assembly line, governance has to become one too.
So let's talk about digital twins.
I love digital twins. Let's do it.
I know. I think digital twins is cool. And this is where factory stops being kind of building blocks and starts being sort of more simulation. A digital twin is a virtual model of a real-world object, a system or a process or even a person that is continuously updated with real data so it behaves like the real thing. It's not just static simulation, though. It's, you got constant data moving into this. A digital twin connects to sensors, software, or operational data, and all these different streams, and mirrors what is happening in real time. That allows organizations to test scenarios, predict failures, optimize performance, and make decisions without experimenting on the physical asset itself.
So imagine a factory floor. Every conveyor belt, every robotic arm, every temperature sensor, every vibration reading streams data into a virtual replica that exists in parallel. The physical system moves, the digital system moves with it. If a machine slows down in Ohio, its twin reflects the slowdown in milliseconds. If a shipment is delayed in China, the twin recalculates the output curves before a human opens a dashboard. Factories use digital twins to simulate production flows before they reconfigure the line. So if you're GM and you want to reconfigure your line, you'll go to the digital twin, which exists in a computer, and you'd say, all right, I'm taking this out, I'm putting it over here, I'm moving this person here, I'm going to let it run. And then you'll see it all blow up and you'll be like, wow, glad I didn't do that, right? That's what the digital twin is for, right? Enterprises use them to model supply chain shocks, and risk teams. We've started, I say we because I cover risk management. We've started using them to run stress scenario before reality, runs them first. It's not just observation. It's actually anticipation.
Do you have digital twins that model political outcomes and
So actually,
pandemics
there's a couple platforms out there where it runs a digital twin, and so you can say. So SAP did this many 2018 many years ago in its board management software, and what it allowed you to do was be like, oh, all right, this is what it looks like today. Like let's flip over to the digital twin and close the Paris office. So you close the Paris office and then hit run and let it predict out. And then you'd realize, oh my God, we all went bankrupt. Let's not close the Paris office, right? So the board could make really good decisions on really good outcomes as long as it understood what the outcome might be. And you didn't need a bunch of people standing around trying to figure that out.
When you layer all the, AI on top of all that twinning, you introduce predictive modeling. The system doesn't just show you what's happening there. It estimates what will actually happen next. Through throughput optimization or bottleneck prediction, failure forecasting, resource reallocation, the assembly line optimized throughput once during design. Neural networks optimize workflows continuously, and the recalculation never stops. So quite an advantage of going, set it all up, run it once, see the outcome versus constantly running it over and over again.
So the factory never sleeps, and now neither does the decision layer. That's new. When Ford optimized labor, the line still depended on human supervisors. Someone walked the floor, someone listened to strange sounds, someone made a judgment call when things didn't fit the pattern. The machinery ran, but the judgment stayed human. But now?
Yeah, now we're building environments where the twin simulates, the model predicts, and the optimization engine suggests or even initiates change automatically. We're not just, because we love The Simpsons. I love the Simpsons episode where he becomes an automotive executive, right? And and what was that guy's
Powell Motors?
Yeah. What was the guy's name? That was trying to teach him the way of the Japanese factories, and all that stuff. And it was,
right.
yeah.
Because they made cars with Japanese names like the tempura.
Yeah. Right? What wasn't his friend's name? Not, oh gosh, now I've got to rewatch that episode. Yeah. He was like Mr. Simpson. Yeah. It was, yeah, anyways, I'll have to cut that out. Anyways. So, these, as I said, these, changes is potentially even generated like automatically when these are running. We're not just, modularizing the labor, we're modularizing judgment itself, breaking expertise into parameters, breaking intuition into weighted probabilities, and breaking experience into data inputs.
You know what a digital twin really is? It's SimCity, except the city's real. And the money's real, and the layoffs are real, and the cascading supply chain failure is very real. We grew up building virtual cities, rerouting traffic just to see what would happen. Now corporations are running simulation on digital replicas of their own operations and saying, let's see what happens if we optimize this node. Except the node might be a warehouse, or a risk exposure, or a team. And when the system suggests you can increase efficiency by 3.2% if you remove this constraint, what that really means is you can squeeze a little bit more judgment out of this loop.
It's SimCity though, but without the flying saucer and the aliens.
There you go. Or maybe it is. I don't know.
I don't know. Yeah, we'll see.
We're going to find out soon.
Yeah, I hear that. Yeah. Digital twins fragment operations. Neural networks fragment cognition. It breaks it all down, as we've discussed. At some point, we have to ask, though, if the model is optimizing continuously and the twin is predicting constantly and the workflow is auto-adjusting in real time, where does the human judgment sit? Because if SimCity taught us anything, it's that optimizing for traffic flow sometimes means bulldozing a neighborhood. And that's funny in a video game. It's kind of different when it's payroll.
Amen.
So let's talk about Renee's favorite thing, governing AI.
I really do love it.
She's going to jump for joy here. When you distribute judgment across millions or billions of parameters, there's no single decision point to interrogate. There's no supervisor standing at station 4 tightening bolts incorrectly. There's no memo that says, here's where we chose wrong. In traditional systems, failure is often linear. A part breaks, a person miscalculates, a process step was skipped. Like, how many times has this happened in production rollouts, right? You could trace the error to a node in the chain. With neural networks, judgment is statistical and distributed. The decision emerges from weighted mathematical relationships across lots of these layers. So if something goes wrong, you're not inspecting a broken lever, you're inspecting gradients, training data, objective functions, and model drift. Accountability requires traceability, but traceability in AI does not mean replaying a human thought process. It means reconstructing inputs, model versions, training conditions, parameter states, confidence scores, and threshold settings at the moment of inference. If an assembly line fails, you inspect the station. If a neural network misjudges, you inspect the system architecture. So you have different tools, different oversight, different skills at the board level. And this is where governance needs to evolve. Traditional audit frameworks assume identifiable control owners and decision authorities. AI systems blur that. The responsibility is distributed across data engineers, model designers, business owners, compliance functions, infrastructure teams, and even model developers. The failure is rarely one actor, it's systemic.
Okay, and all of this is not anti-AI. Renee is not anti-AI. It's pattern recognition. We've seen this movie before. When factories scaled muscle, society had to build labor laws, safety standards, inspection regimes, and regulatory oversights. Efficiency surged, but so did accidents and exploitation until governance caught up. Now we're scaling cognition. We're industrializing inference. That seems crazy. And just like in factories, the question is not whether efficiency increases. It will. The question is who designs the system, who sets the optimization targets, and who will absorb the downside when it fails. Because AI systems don't optimize truth. Again, they optimize objective. If the objective is speed, accuracy may suffer. If the objective is engagement, extremity may increase, right? We get more extreme. If the objection is cost reduction, well, then we won't give it to a human to review because apparently we're more expensive. I'm not sure how, but we are. AI governance begins at the objective function. Who decided what the model's trying to maximize? Who approved the acceptable error rate? Who determined the risk tolerance? Those aren't technical. None of those are technical questions, right? They're governance questions. And there's a second order issue. The black boxes concentrate power, right? If only a small technical elite can understand or interrogate the system, decision authority shifts away from traditional oversight bodies like boards, regulators, and even executives. They're all going to depend on expert interpretation of model behavior that they can't even independently validate. I mean, if you thought they had problems with the CISO, wait till you get a load of this. That creates asymmetry. The more complex the system, the more governance must move upstream. Documentation. I know you guys hate it. Model inventories. Oh, God, we got to keep a spreadsheet. Impact assessment, not more impact assessments. It's scenario stress testing, continual monitoring, clear human override protocols. You cannot supervise a cognitive factory with industrial age controls. So no, this is not anti-AI. It's pro-accountability. We optimized muscle and built OSHA. We're optimizing the mind, and we have to build its equivalent because once judgment is automated at scale, governance is no longer optional architecture. It's structural infrastructure. And the longer oversight lags behind capabilities, the wider the trust gap becomes. So let me say this. So I worked in banking. And so there's a lot of banking regs, and I almost never care. I worked in IT, right? I managed the data center, so I didn't really care about the regulations that the financial people were doing. I had my own problems. I had 11 audits a year. I'm busy, right? But one of the things I did manage to read lately was something that the Office of the Comptroller of Currency, the OCC, they're the banking regulators for giant banks, big banks, Bank of America, JP Morgan, places like that. And they have something called model risk management. Now, this is financial models. These are the models that are determining credit scores and also. So model risk management says, you have to do change management. You have to do incident management. You have to do problem management. You have to keep track of all this stuff. You have to have an inventory. People have to own it. You have to know who owns that thing. You have to know how often it changes. And you have to test it before it goes live. And one more time, you have to make sure that the data stays current. And you have to understand when the data is no longer usable, because if the data is no longer usable, you're now making decisions on bad data. All of that is true for, guess what? AI. So if you're looking for a shortcut to, what would that look like? Go download the OCC requirements for model risk management. It's I think 281 pages. And if you're a nerd, you'll love it. You'll love every minute of it. So we do have ways to do this, right? And if you ask me, Mark, I mean, how does this not sound like IT, right? I mean, we do incident management, we do problem management, we do change management. We know who owns machines. We know who owns applications. We do all kinds of stuff around that. Why aren't we doing it with our AI models? It's the same difference to me.
I agreed, but I think it's the black box problem, right? I mean, I've been in banking too, and lived in banks, tier 1 UK banks, right at the time when all of this Gen AI, stuff is kicking off, and everybody says you have to have Gen AI in your chatbots, and you got to do Gen AI in this, and you got to use AI in this and that. And when you outsource the model, it's kind of tough because if you outsource your model to Microsoft, I'm not going to name names, right? But there's several banks that have used Microsoft to do certain things. And when you have that model in somebody else's control and they change that model, and then that changes the outcomes that whatever that agent or that that process that depended upon that model, when those outputs change, because they will change, and you didn't know about it, that's a problem. And believe me, the regulator is going to be all over you, because they were all over, banks when that happens. And it happens all the time now.
I tell everybody that, your biggest headache isn't going to be your CEO. It's going to be your auditor. Because you cannot stand there and say, I don't know, I listened to the AI. Because if I were your auditor, the next thing I would say is, are you crazy? Like, what was it doing? I don't know. Who was in charge of it? I don't know. Why did you listen to it if you don't know any of this? Because everybody does. None of that works. None of it works. You are never going to get away with that. So
no, I think
comfy with documentation.
I agree. Get comfy with documentation. And I think it's a short-lived problem, right? Because regulators are wise to this now. Banks, and particularly the financial sectors, that's where I live. They figured this out, and they got excited, and then they got cautious, and then they got, a little more, excited again, and started putting controls in place and, managing change around models and change around risk behavior and that, but it's emerging. But, nobody does this very well today, right? And so when you throw in one more thing, it just, and it's supposed to make life easier. It's supposed to make it all shiny and fun, and it's just less transparent.
Yeah, I would say it's less transparent, and I would say that the current state that we're in with AI, I keep telling people, man, they're interns. It's when you hire an intern, would you be like, hey, why don't you do all the financial modeling for me and I won't question you ever? You would never do that, right? Why don't you tell me what the business strategy is and I'll never question you? It's no, it's an intern. Stop it. Why don't you go get me the information I need, bring it back to me, and I'm going to figure out what to do with it, because that's what this is for, right?
Yeah.
And I always think don't be, you would never let an intern do that. Don't let AI do it either. That's crazy.
I mean, we talked about this before, right? There's a difference between large language models that are sort of general purpose and small language models that, I think will be more useful when they have very specific use cases and very specific training data. But again, you throw in bad data in, bad decisions out, AI gets bad decisions to model, it's going to make equally bad decisions. So, people got to figure that out and reconcile that.
MIT did a study, and what they figured out was people by themselves make terrible decisions.
Terrible.
50-50 maybe, right? Just terrible. Machines by themselves make terrible decisions, 50-50. People and machines make incredibly good decisions.
Yeah.
So there's something happening there where the person has a level of context that machine will never have. And together, they're actually able to do really, really good work. And I just want everyone to remember that. So all the doomsdaying and all the, everybody's going to lose their job, analysts won't exist anywhere in the world, that, none of this is true, right? We need each other if we want to do a lot of good work. Now, if we all want to do slow work and just take home a paycheck, then we can either work separately from each other. I don't really care. But at the end of the day, I don't feel like any of this is going to displace me. I don't think it's going to do it.
I mean, we talked about this before, right? Excel didn't, eliminate the accountant class.
Right.
It's going to change change the nature of work. It's not going to change, how many people are working. Not significantly, I don't think. I don't know. It's not.
So Pew
yeah.
Research just did a study, and they went and asked something like 8,000 CEOs, how much more efficient did AI make you? Like right now, how much more efficient is it making you? And they're like, maybe 3%, maybe 5%. Like it's not as revolutionary as everybody thinks it is. And so, I hope one day it is. Like I hope one day air traffic controllers don't have to sit there with their eyeballs pinned open for 8 hours a day because that stuff's easier to do. So like, I do hope some of that is true.
Well,
anyway,
so one last thing on this, because I think it kind of hits to the point of why, you're not seeing efficiency in these sort of massive, amazing numbers. It's like, okay, if you've ever used ChatGPT or Claude or one of these, okay. Okay, there's definitely a little bit of a learning curve. But if you're using it every once in a while, what happens to the conversation you're having is it compacts the conversation. And this is a process that happens in the background. And what's happening is, it takes your conversation and it compacts it, and it uses AI to summarize your previous information. So it's not like it keeps all of that information in context all of the time. It literally compacts that, and then that becomes the new context. And so if you have errors or issues or, let's say inconsistencies.
Well, you trained it differently as you were going, right?
That's right.
I don't want to talk about this. I want you to zoom in on this. And then it just starts to become unwieldy. Actually, it really gets hard to manage.
Right. So the human brain, the context that a human brain can carry is much, much greater than a single ChatGPT or Claude or whatever conversation. And yes, these, they use data, they summarize data, they can, kind of operate on what's a predictable outcome. But that doesn't change the fact that, humans have a much greater capacity than AI, does on maintaining that capacity, that context around those conversations. And, it's a human advantage there. Yeah.
That's why AI needs us. That's why together we all make good decisions, right?
Right. Exactly.
So listen, maybe Henry Ford did bring us to where we are today. The assembly line made cards affordable. It also made labor repetitive. Neural networks make thinking scalable, but I'm just scared for what they're going to make repetitive. What's next?
Optimization is powerful. I think nobody's going to argue that. We have to understand what we're fragmenting, though, because Ford fragmented the motion, all throughout the assembly line, and AI fragments judgment. Governance has to evolve around that. So there we go. Thanks for listening. This is the Nostalgia Nerd Podcast, where factories become algorithms and childhood history becomes modern infrastructure. Thanks for tuning in. Subscribe, follow, share, like, review. You know what? We've got like 3 or 4 or 5-star reviews on iTunes, which is great. We have way more listeners than that. So I know that everybody that's listening right now, they can easily hit the 5 stars, and that really helps us get exposed to new people. So please do that. And share it with somebody that remembers punch cards and maybe now builds neural networks. So next week, more tech history, more modern consequences.
Thanks, Mark. Just the numbers in the card. Set the route, mark the field, run the deck.